Hello friends, welcome to my channel. In today's session, we're going to talk about circuit breaker pattern in microservice. So in microservice, there are multiple design patterns available like aggregated design pattern, a chain of responsibility, API gateway, decomposition, branch design pattern, CQRS, command query responsible segregated design pattern, and the circuit breaker is also one of the design pattern in microservice. So basically the design patterns is provide us to solve some problems which we are not overcome or facing in the microservice environment, right? So let's see what circuit breaker pattern is solving the issue in the microservice. Let's see. So before talk about the problem and solution, I want to give some technical definition of circuit breaker pattern. The circuit breaker pattern is a design pattern that falls under the sustainable design pattern category. It allows developers to prevent cascading failures in microservice architecture by invoking remote services through a proxy. Basically it is prevent the cascading failures in microservice. So let's see what is the problem that we are facing and how this circuit breaker solves that problem. So let's say I've designed one application. The application has two different microservices. One is service A, service B, and service A make a request to service B, and service B will accept the request and respond back to the service A. So this is a very simple workflow. If some cases, if service B is down, is not capable of handling the request. So that case, what happens? Your request will be failed and it will timed out, and you will not get the proper response from service B. And also you're not giving some time to service B to recover. Okay, these are the problem statements in this scenario. So how to overcome this? So the solution, we can introduce or implement circuit breaker in our code to resolve this issue. Let's say I have service A and it start sending request to service B, right? In some scenario or some time of uh, due to some workload or it's not workload, it's a request load, right? So the request load, the service B is going down and it's not able to handle the request from service A, right? So if I implementing the circuit breaker, what it do, it will monitor the request. So it will keep check the threshold whether the failure threshold is met, what I've configured in the resilience port shape configuration. For say, if 10 request is failing, okay, then I don't need to process any request. Just stop the request and send the error message to service A. So this is what the rule or the process is followed in the uh, circuit breaker. Okay, so like say the 10 request is failing and it keep monitor the failures count. If 10 request it's failed, then immediately the state will become open. So in circuit breaker, I have different states that I'm going to cover in the upcoming slide. But for now, the state will become open so that it stops the request. Basically, request to block the request from A to B, right? So let's take one real-time example for understanding better. So in all our home, we have electric circuit breaker, right? So what is the role of it? Whenever there is a abnormal behavior in the power supply, so the circuit breaker will turn off the power supply so that it will not damage the electric devices. So it will save the part, right? So it is similar kind of behavior. So it is more, uh, so it more like over like it's giving some time to the service B to recover, auto recover or auto heal from the load. Okay, let's see what are the advantages of circuit breaker. So helps to prevent cascading failures, handles error gracefully, and provide better user experience, reduce the application downtime, suitable for handling asynchronous communications. State changes of circuit breaker can be used for error monitoring. So these are the advantages points. And so as I mentioned, we have states in the circuit breaker. Those are like close, open, off, open. So let's go one by one and let's explore what is each state means. Okay, let's go into the next slide. So what does circuit breaker patterns work? How does circuit breaker pattern works, right? So here the states like closed state. The initial state of the circuit breaker or the proxy is the closed state. The circuit breaker allows microservice to communicate as usually and monitor the number of failures occurring within the defined time period. If the failure count exceeds the specified threshold value, the circuit breaker will move to the open state. If not, it will reset the failure count and timeout period. Example, whenever initial process, the circuit breaker state will be is closed only. So closed means you are allowing the request from service A to service B. So it will not stop the request. It will process the request and get the response. So now the responses are successful. There is no issue, right? So in that case, your state will be in the closed state. So let's see what is the next one, open state. So once the circuit breaker moves to the open state, it will completely block the communication between microservices. So the particular service will not receive any request and the user will receive an error from the circuit breaker. So that means like if I specified if my failure request, right? Failure request like around 10. Just I'm giving some number 10, right? If my threshold value met, if the 10 requests are failed, so then immediately what happens? My state moved to open. So that means it will completely block the communication between microservices. So it will not allow any request further. And the circuit breaker will remain in the open state until timeout period ends. So there will be a duration that we can set. For example, for every 1 minute, okay. So after change the mode to open state, I want to keep monitor every 1 minute if services back. Okay, then it will try to move it to off open means it will slightly open the state will become to off open and it will send few requests. So let's see in the next topic. Yeah, okay, the off open state. In the off open state, the circuit breaker will allow a limited number of requests to reach article service. If those services are successful, then circuit breaker will switch the state to closed and allow normal operation. If not, it will again block the request for the defined time period. So this statement you understand, right? So it will try to allow some limited number of requests to the other microservice service B micro sorry the service B, and if those requests are successful, then the circuit breaker will switch the state. Now the state will change to closed. So if it is closed, if closed means your request will process normally. So closed means your service B it's working as normal. There is no issue with the service. So that is the meaning of closed. So now this is like maintain every it will keep monitor your request. Whenever there is more failures in the request, immediately the state will become open and your service request will be stopped and it will send some error message to the end user, so that they will aware that the services have any some issue with the service. So that kind of message will be sent back to the uh, as a error message. Okay, and this part you understood. Let's see the quick workflow diagram. As I mentioned, it will be in the closed state initially. Then once it met the threshold limit, then it will become an open state. After open state, after given some time duration, it will try to do the change the state to off open, and off open it will try to allow few limited requests to process. Once the limited request or success, then it will switch to closed state so that it will be normal. If still the request are failing, then it will back to open so that it will not process any request. It will return the error message. So here the circuit breaker has maintaining sliding window type. So sliding window type basically, so whether you are going to tell whether it's a time based or count based. For example, if this many time each request is not processed some given timeout kind of thing. So then that is also will be configured or count based number of requests basically. So if you look at this, we need to configure these many parameters in our property files, and so here, right, this resilience 4G is a dependency in the cloud Spring Cloud Starter circuit breaker hyphen resilience 4G. This is the dependency we need to add in our form.xml, and sliding window size 10, and by default count base is the default window type. So here I've configured a minimum number of calls 10 and permitted number of calls in off open state. So I want to just process 4 requests, and if this 4 request is success, then only I'm switching back to the closest state, right? And also what is the failure threshold rate? Those all the configuration I've defined in this property file. Based on this property, uh, it will change the states, whether it will be uh, closed. I mean, whether it's be open state or it's like a back to close. So this can be handled based on this configuration, right? So the sample code, this is not exact code, just I'm giving you an idea. So we have annotation like criteria, circuit breaker, and the name of the circuit breaker, and the fallback method. Fallback basically it returns some message, error message to the um, as a error message to the requested service, and this is a sample code. You can implement a circuit breaker class also. So in upcoming session I'll try to give some demo over on this. So just for understanding, just I'm giving you some a quick code snippet so that it'll giving you some idea to you. So yeah, that's what I planned for today, and we'll catch you in the next video. Until then, thanks. Thanks for watching. I hope you enjoyed this video. If you did, please be sure to hit the thumbs up button and subscribe to my channel for more great content. I post new videos every frequent, so you don't want to miss out. Thank you.